All right, everybody. So here is our week 3 PowerPoint. So pretty much we're just going to be going over the basics of physical science, and then I'm going to talk very quickly in the beginning about ck12.org. You should have got an email with a class code, if you will, and so you want to go to that website and sign up because that's how our platform will be presented, or our class will be presented for the rest of the semester. It'll make things nice and easy, and it'll also let you work at your own pace. So the link that I sent you in your email, which is also on Canvas in the announcements, and I also sent you a Canvas message, this is the video for it. Now, I'm not going to play it because I would like you to go there and watch it, but this is going to be what you're going to see in that link, and you're going to click on it, and it's going to tell you everything you need to know about how to operate the CK12 platform. I want you to try and get this going. If you have questions on it, always let me know. My contact is always on Canvas. I will get back to you as quickly as I can, and also remember to sign up for the Remind app. So I'm going to go through this week's lesson with bits and pieces from the unit you're going to be doing on CK12. So we want to talk about the basics of physical science. Last week we talked about the scientific method and how it is used in critical thinking, which is very important. So if we want to talk about the basics of physical science, we're going to start with matter. Matter is just anything that takes up space. So your matter, I'm matter, the computer or screen that you're watching this on, that is all matter. And so in the instructional part of the CK12 unit, you're going to see these exact same little blurbs, if you will. And so this is where you'll want to read through the material. You'll do those practices, and at the end of your CK12 unit, you'll have a quiz. Now that quiz, you can take it twice, and we take the highest score of it. So where it says here, what's the matter? So all the stuff that exists, anything that takes up space, anything you can see and touch and feel, that is matter. And you can see there, in science, matter is defined as anything that has mass and volume. Now, we're going to get to both those terms as we go through here, and the first one is mass. So mass is just the measure of the amount of matter in a subject or an object. It is usually measured in kilograms or grams. If it's really light, you could say, milligrams. Heavier stuff is usually in kilograms and whatnot. But I have this visual up here of a golf ball and a beach ball. Both of them are matter. Now, in terms of what kind of mass they have, the beach ball, it's just like that plastic coating with a bunch of air inside. So there's not much mass to it. But that golf ball, inside of it, there's a cork, there's a bunch of winding, and then there's the hard outer shell. So there's more mass packed in to that golf ball than there is the beach ball, even though the beach ball takes up more room because it has a higher volume. The air that goes inside of that beach ball, and you can think of volume as anything that is taking up, that I shouldn't say taking up space, but anything that can be filled. So like a beaker, a graduated cylinder, and we'll get into all that. But in terms of mass, matter, and volume, the golf ball will have more mass than the beach ball. They are both matter, but the beach ball has more volume because there's more space for stuff to go inside of it. And we'll talk about that on this slide. So when we're getting to mass versus weight, because it's an important thing we want to talk about, and you're going to see this in your unit. There'll be questions in the practice and on the quiz. You can see here I have a little astronaut on the moon and a little astronaut on the Earth. Now, when we talk about mass versus weight, so mass is just how much matter is in an object. That astronaut has the same mass on either the moon or the Earth. The mass doesn't change. What does change is the weight, because weight is affected by gravity. So the Earth has more gravity than the moon, therefore that astronaut weighs more on Earth than he does on the moon. And so that's the key critical difference between mass and weight. Now, when we talk about volume, so they say volume is a measure of the amount of space that a substance or an object takes up. So the basic unit for this is the cubic meter or cubic centimeter. If you've ever watched a medical show where they say, I need 10 cc's of whatever stat, that cc is a cubic centimeter, so it's a volume. And so you can look on the right here, I have a beaker with a little bit of fluid in it, a graduated cylinder, and also a balloon. Each one of those has a volume to it, meaning that there's a certain amount of stuff that can be placed inside of it. And so that is our key difference between mass, volume, weight, and matter. So if we just summarize real quick, everything is matter that takes up space. Mass is how much matter is packed into a certain area, and volume is the amount of space that a subject can take up. So there we go. There's our key differences there. And like I said, these are definitions and slides taken right from your CK12 unit. And so now in the unit, they talk about volume by water displacement. So if I have, a beaker that takes up, 100 milliliters, I know definitely the volume of that beaker, 100 milliliters. But what if I had this little toy dinosaur and I wanted to find the volume of it? That might be really, really hard to do because it's an irregularly shaped object. Typically, if we want to measure volume, we go length times width times height. So if I have a box and I want to know how much stuff can fit inside there, I measure the length of it, the width of it, and the height of it. And that tells me how much volume it has. Well, something like this dinosaur, that's not easy to do because it's very irregular in its shape. But what you can do, so you can see here on the left-hand side, say we had this dinosaur and we had a graduated cylinder. And you can see where the curve of the water matches up. It's about, 4.1, 2, 3, 4. So about 4.8 milliliters, we'll say. Oh yeah, there's has on the bottom. That's neat. But then when we dunk the T-Rex or the dinosaur into the liquid, the amount that the liquid moves up, or the amount of fluid that is displaced, if you will, is equal to the amount of volume in the dinosaur. So you can see there the displacement method for measuring volume is you add water to a measuring container that you can easily read, you place the object into the water, and you measure the difference that has been made now. How much did it go up by? So that amount it went up by is the volume of that irregular shaped object. So if we look at the bottom here, it says the volume of the water alone is 4.8 milliliters. The volume of the water and the dinosaur together is 5.6 milliliters. Therefore, if we subtracted the two, the difference would leave us with 0.8 milliliters, which would be the volume of the dinosaur. So you can think of it this way. If you had a completely full bathtub, like up to the very top, and then you dunked yourself in it, completely submerged yourself, the amount of water that would flow over the side is going to be equal to the volume of your body. Kind of cool. It's a neat way to measure irregular objects. And so now we also want to talk about physical properties, and we're going to talk about the difference between that and chemical properties. With physical properties, they are properties that can be measured or observed without matter changing, and we'll talk about what that means. So the matter won't change into a different subject, but physical properties are things you can usually detect with your senses, meaning you can smell them, you can feel them, you can hear them. Other ones are on the bottom right hand here: odor, boiling point, the ability to conduct heat, electricity, to dissolve in other substances. Those are physical properties. So I have this little graphic here of McLovin from the movie Superbad, just because a license tells us a lot of physical properties, things that we can sort of see with our eyes and our senses. Hair color, eye color, height, maybe not weight, but you can maybe sometimes estimate it. So that's a lot of physical properties, like physical characteristics. And so now let's talk about density, because this is also in your unit as you go through it. So density is a measure of how tightly the matter in a subject or substance is packed together. So everything at the atomic level is sort of packed in. And so density means, is it tightly packed in, or is they widely spaced? So once again, if we're talking about the ratio of mass to its volume, which we have in that little equation there, density equals mass divided by volume. So how much matter is packed into how much of a space, essentially. So this beach ball, it could be huge, it could be massive. So there's a lot of volume there. but there's not a lot of mass. It's just that plastic covering keeping all the air inside. Therefore, it doesn't have a very high density because the mass is very small compared to the volume. Now, the rock on the right-hand side, sure, it may not be as big, but I bet you don't want to be hit with it because it is very dense. So it has like a density to it because the volume is very small, but the mass is very high. So that leads to a higher density. And so you notice in this equation that density, it is directly related to that volume. If I keep mass the same, if the volume goes up, the density goes down. If the volume goes down, the density will go up if mass is held the same. So it's an important thing for us to know. And like I said, this is all within your CK12 unit, and you'll be able to read up on anything that has given you any sort of problem, and you can also ask me. Okay, so now we have chemical properties, which are much different than physical properties. Because when we're talking about chemical properties, we're talking about chemical changes. And chemical changes mean that you are turning one substance into something else entirely. And so these are properties that can be measured or observed only when matter undergoes a change to become an entirely different kind of matter. So they're saying here the ability of the iron to rust. So this little picture here of the shovels. The one on the right, very clean, shiny, nice iron. You leave it outside, air gets to it, water gets to it, and it rusts. So that rust is called oxidation. And so the iron now becomes iron oxide. And you have a chemical change taking place, and that's a chemical property. Right below it, I have a picture of those fireworks. Reactivity, like how something reacts to a heat source or an ignition source, is a chemical property. So those fireworks, it's just, metal salts packed into a container, but once it is ignited, we get these big, beautiful explosions, and it's an entirely different substance. One of the best things I can equate it to is making a cake. So if I have all the ingredients on the left-hand side there, and so let's say I mix all those up and I make this beautiful cake on the right, I cannot reverse that process now. I can't take the cake and make it into those ingredients. They've undergone a chemical change, and they have different chemical properties now because I mixed them all together and I heated them up to where with physical properties, they are reversible, like we will see. So a pure substance, because this is the next section on your CK12 unit, is called an element. And this will be important as we move forward with our class to understand an element, because we are going to get into chemistry pretty quick here. So an element is a pure substance because it cannot be separated into any other substances. So if I had a brick of gold, no matter how many times I broke that down, every atom of gold, which is an element, will have the same chemical properties. So this says some elements are very common, others are very rare. The most common element in the universe is hydrogen, which is true. And then below here I have the periodic table of elements. So every single element on that chart is a pure substance, meaning that if you found a chunk of any of it, it's all going to have the same chemical properties. And I put uranium on here just as an example. It's my favorite element on the periodic table. But every piece or every atom of uranium is going to have those same chemical properties. It is a pure substance. It is not being mixed with anything else. Okay, so now physical changes as opposed to the chemical changes. So physical changes is a change in one or more of the physical properties, but you are not switching the substance. You're not creating anything new. So if I have this Coke can on the left-hand side and I crush it, I step on it and I smash it. Okay, it's now flattened, but it's still a Coke can. It didn't rust, I didn't melt it, it's not something new. It's still a Coke can, just in a different form. Same way if I have a piece of paper and I cut it. Well, I can cut it into a bazillion pieces if I wanted to, but it's still paper. It hasn't changed into something else. I didn't burn it. It's not ash. It's just paper. And then lastly, on the far right there is just an ice cube. If I have an ice cube and it melts, well, now I have water, but it's still the same H2O. It's still water, just in a different physical form. If it then evaporates or turns into steam, okay, it's a different physical form, but it is still water. So these are only physical changes. We're not changing it into something new. And one of the ways you can detect this, like I was saying with the cake, so the cake I can't reverse and go in the opposite direction. I can't take a cake and break it down into the ingredients, but I can take ingredients to make a cake. Well, if I had this ice cube, even if it was steam, well, I can cool it down into water, and then from the water I could freeze it back into the ice cube. So that process is reversible. And that's one of the big ideas with chemical changes. And then the last section you're going to have on the CK12 unit is the law of conservation of mass. Now, this is incredibly important in the science universe. It is one of the biggest and most important laws because it lets us know that the mass of any material beforehand will be the mass after. Meaning that if I had these logs over here, if we look at this little example, and I started a campfire, and I had all these logs and I burned them, and in the morning I just had the ash left over. Well, it didn't just magically go away. If I was able to collect all of the ash and all of the smoke from the fire, it would equal out to what I had before. So say if I had 10 pounds of logs and I burned them, well, the mass of the smoke and the mass of the ash will equal that same 10 pounds. That is a truism throughout science. And on the right hand side here I have a little supernova here, because it works even on the biggest scales. If a star explodes, the mass it had before, once it explodes and all the gas and material goes out into space, if you can gather it back up, it would equal the mass that it was before. So it is a very important truism in science. Okay, so that is it for this week's lecture. It was just nice and quick. Main things I want us to do. So here's like our to-do list for this week. Watch this PowerPoint, boom, you've done it. If you haven't already, sign up on the ck12.org. I'll talk about it more when we Zoom, but the sooner you do that, the better. So you're going to work on that week 3 material, like I said, at your pace. A lot of you have already commented on the discussion board. That's why I have it checked off. But if you haven't, please do. All you're doing is signing up for CK12 and then telling me you did it. And then at the end of the CK12 work, you're going to take the quiz. And if all this seems really confusing, watch the video in the beginning of the PowerPoint. That will explain everything. And then after that, enjoy your weekend. Take it easy. Just get that work done. Don't stress too much. And I will talk to you all next week. Actually, I'll see you in the Zoom tonight. But presentation-wise, I'll see you next week.